Okay, in today's session we're going to talk about section C, or part C of the readiness exam, which focuses on factoring polynomials. Alright, and when it comes to factoring, we typically want to think of that as undoing multiplication, somewhat like division. We want to do the opposite of multiplication, or undo multiplication when it comes to factoring. In problem number 1, the problem is asking to write an equivalent expression by factoring out the greatest common factor. Greatest common factor we typically hear as GCF. Okay, and basically all they're wanting to know is, if we're looking at problem number 1, first of all, let's look at the coefficients. Coefficients being the numbers out in front of the variables. Okay, and what we want to do is see if there is one number that goes into each one of these coefficients. So in this case, a number that goes into 24, 24, and negative 30. So is there a number we can think of that goes into 24, 24, and negative 30? Alright, so off the top of our head we say 6 would. Okay, 6 would go into 24 4 times, 6 would go into 35 times. Alright, so that takes care of the coefficients. Then you shift your focus, after you've checked for the coefficients, you shift your focus to the variables. And with the variables, what you want to do is see if that variable is located in each term of the polynomial. Alright, this particular polynomial has 3 terms. 1, 2, 3. 3 terms. Okay, and so what we're trying to do is look at each of these 3 terms and see if there is a variable that's common to all 3. In this case, we have an x in each term. Notice x there, x there. Alright, and we have a y in each term. A y right here to the 9th, y right here to the 7th, y right here to the 4th. So we've met the check of seeing that there's a variable in each term to be factored out. Okay, so let's clear this up a little bit. Erase that. Erase that. Alright. Now, we've decided that x exists in each term and that y exists in each term. Or does it? And we said yes, it does. Now, once we decide that each of these 2 variables exists in each term, we want to pull out the smallest number that we see present, or the smallest exponent represented by that variable in each term. So when we're looking at the x's, we see an x to the 8, we see an x to the 5th, and we see an x to the 2nd. So when looking at the x's, again, x to the 8, x to the 5th, x to the 2nd, the smallest we see is x to the 2nd. So we want to pull out that number. So x squared, or x to the 2nd. Do the same thing for the y's. We have a y to the 9th. In the middle we have a y to the 7th. And at the end we have a y to the 4th. The smallest number or exponent of those y's being 4. So that's what we pull out. And then we open up parentheses and write what's left of our 3-term polynomial after factoring out a 6x squared y to the 4th. Okay, so basically what we're saying is, if we had 24 x to the 8 y to the 9th, and we wanted to divide it by what we're pulling out here, so 6x squared y to the 4th. Okay, if we want to divide it by that, 24 divided by 6 is 4, so we write out 4. X to the 8 over x squared. When you're dividing variables with exponents, you subtract the exponents. Okay, so 8 minus 2 would be x to the 6th. And then for the y's, y to the 9th over y to the 4th would be y to the 5th. Alright, so that would take care of the first term. So then you look at this term in the middle. So now you shift your focus to the middle term. Okay, so once again it's a 24, but now it's x to the 5th. Erase that and that. So now it becomes x to the 5th and y to the 7th. Still dividing by what we pull out. Still dividing by the 6x squared y to the 4th. So once again, 24 divided by 6 is 4, and it's a positive 4. Here, let's write this answer over here. Give ourselves some room. Okay, so we have our 6x squared y to the 4th pulled out. We just said we have 4x to the 6th, y to the 5th. So now we're working on the middle term, which is the 24, x to the 5th, y to the 7th, as we've circled right here. So now when we divide, that 24 divided by 6 gives us a positive 4. X over x, x to the 5th over x squared gives us x cubed, or x to the 3rd. Y to the 7th over y to the 4th gives us y cubed, or y to the 3rd. Okay, so that takes care of the middle. So now we shift our focus to the last term. Okay, so if we're using the last term, get rid of this up here, and we write negative 30 x squared y to the 4th. Okay, so negative 30 divided by the 6. Okay, again, we're dividing this third term in the polynomial by what we've decided to pull out, what we've decided we could factor out, our GCF, our greatest common factor. Okay, so the negative 30 divided by the 6 is a negative 5. You have x squared over x squared, so those will just cancel each other, so you don't have any x's left. You have y to the 4th over y to the 4th. Anything over itself cancels. Alright, and so you're just left with this negative 5. And that, because you factored each term of the polynomial, you factored all three terms, you are now finished. Here's what you got for the first term, second term, last term. Alright, so that would be our final answer. So in this case, our final answer would be, let's see, 6x squared y to the 4th, 4x to the 6th, y to the 5th, 4x to the 3rd, y to the 3rd minus 5. So it looks like our answer would be C. Okay, so C would be our answer here. Alright, let's just erase all of that, clear some things up. Okay, moving on to number 2. Now that we got the hang of what we're doing, we'll go through number 2 a little bit faster. But understand now that number 2 wants a negative coefficient. So once again, they want the GCF. Alright, but they just want it as a negative version when we pull out our GCF. Pull it out in negative form. Okay, so first, again, we look at the coefficients. So that's the negative 25, the positive 15, and the negative 10. And we figure what's the greatest number that goes into negative 25, 15, and negative 10, greatest common factor. And in this case, it would be a negative 5. Okay, negative 5 goes into each of those coefficients. And then we look at the variable. Well, our variable in this case is u, and each one has a u. Each term has a u. You have a u right there, you have a u right there, and you have a u right there. So each term has a u. You can pull out a u, and as far as determining the exponent to put on the u, we count. We look at all the u's present in the polynomial that's given to us, and we write down whatever the lowest exponent that's present. So we have a u to the fourth, a u to the third, and a u, which is the same as saying u to the first. So since this is the smallest exponent for our u's, we just stay with the u that we have here. Okay, so we know our GCF that we're going to pull out is the negative 5u. Okay, so we write our initial polynomial okay, and once again we're going to divide each term by the negative 5u. That's all we're doing. Taking each term in the initial problem, the initial polynomial, and dividing each term by the GCF, which is a negative 5u. Okay, so negative 25u to the fourth divided by negative 5u. Negative divided by negative is a positive. 25 divided by 5 is 5. U to the fourth over u to the first, u to the 4 over u to the 1. 4 minus 1 would be u to the third. Okay. Then you have positive 15 divided by negative 5, which is a negative 3. U to the third over u to the first. 3 minus 1 be u squared. And then last, a negative 10 over a negative 5. Negative and negative is positive. That gives us a positive 2. U over u, the u's would cancel, and you'd be finished with just saying positive 2. So once we find out everything that we have left, we write what we pull out times what would be left. To get our final answer. Okay, so in this case, this is negative 5u to the third minus 3u squared plus 2. Okay, so it looks like it's a, let's clear some of this up so we can see what we have here. Alright, so yeah, it looks like the answer here would be A. Negative 5u to the third minus 3u squared plus 2. That is correct. Okay, moving on. Starting with problem number 3, what we're dealing with now is trying to factor trinomials. And basically, when we're given a situation like this, we want to use the reverse of the FOIL method. We talked about the FOIL method when we were reviewing for test B, which is multiplication of polynomials. And we said the FOIL method is applicable when you're trying to multiply two binomials by one another, and the result of multiplying two binomials by one another that we're working with anyway in this particular case yields a trinomial. So what we're trying to do with number 3 and the following problems will be to undo these trinomials to get the factors that would initially be used to multiply to get the ending trinomial. Alright, sounds like a lot, but let's see if we can simplify it just a little bit. So let's erase everything. Okay, number 3, x squared minus 2x minus 15. Alright, so what we're trying to say is if we're given x squared minus 2x minus 15, we're saying we're knowing it's going to give us two binomial factors. Alright, two binomials are going to be multiplied together to give us x squared minus 2x minus 15. So by using the reverse FOIL method, I know whatever is going to be in the first position here and whatever's going to be in the first position here, when they're multiplied, they will give me x squared. So to get x squared, I know I have to say a x times an x. So x times x would give me x squared. So that takes care of that. Okay. Now, by this negative 15 being in the last position, I know whatever I put here times whatever I put here has to give me a negative 15. Well, I know just in general, basic factors of 15 are 1 and 15 and 3 times 5. These are the two sets of factors that will give me 15. Okay, so I'm going to use the 3 and the 5, because what I also know is once I write down these factors, that when I multiply the outside by the inside, it's got to combine to give me this negative 2 in the middle. So I can see getting a negative 2 if I'm combining negative 5 with a positive 3. Okay, so let's put it down. So we have a negative 5 and a positive 3. Alright, so we'll just write them down. So now, in essence, we're finished. We have two binomials present here. Okay, and we know that the first times the first gives us this first term. We know the last times the last gives us this last term. Notice, positive 3 times negative 5 equals a negative 15. So in essence, we're finished. We've completed the problem, but we're just not sure that it's right. Now, the way that we find out whether or not what we've done is right is by doing an outside-inside check. Okay, let's clear some of this out of the way. Alright, so with our outside-inside check, once we've filled in our two binomials, what we want to do is see if we multiply the outside, which is a negative 5x, and we multiply the inside, which is a positive 3x. 3x minus 5x combine to give us a negative 2x. So anytime our outside, which was this, and our inside, which was this, when they're combined, they should give you the middle term. And if that happens, then you know you have the right factors. If you don't get that middle term, then you would not have the right factors. Okay, so we know that the correct factors would be x plus 3 times x minus 5. Alright, so what we want to do is, in number 3, look for one of these two. Since they're only giving us one factor as a choice to pick, we have to see which one of these two factors is given to us. Alright, x minus 15 is choice A. That's not one of the two factors we have over here. X minus 5 is choice B. There's x minus 5 right there, but let's double check everything. X minus 3, we don't have an x minus 3 over here. D is x minus 1, we don't have an x minus 1. So as we figured, B, x minus 5 would be the correct answer. Okay, moving on to number 4. Alright, number 4, we have p squared minus 16p plus 63. Okay, and once again, we know the p squared is our first term, so we have something in the first position here times something in the first position in the next binomial has to give us p squared, so we know that's p times p. P times p, first position, first position gives us our first position. Now we're thinking about 63. Okay, so 63, what do we have? A 9 and a 7. We know 63, one of the more common pairs of factors for 63 is 9 times 7. And I like that because I know a 9 and a 7 can be combined to get to a negative 16. Okay, so I like this choice of using 9 and 7 to get my 63. Alright, so now I go plus 9 and plus 7. Okay, now pay attention here. I'm doing something here intentionally, and I'll show you what I'm talking about in a second. Alright, so once again, we finished. We said our first in this parenthesis times our first in this parenthesis has to give us our first in our initial trinomial, and it does. P times P gives you P squared. Then we say our last in this parenthesis times our last in this parenthesis has to give us our last in our trinomial. So 9 times 7 gives us 63. So we're actually finished, but we're not sure if we're right. We finished the problem, but we have to check it to make sure it's right. And what we're checking for is to see if the outside and inside combine to give us this negative 16p in the middle. So what we want to do is multiply the outside by the inside. Okay, so on the outside, p times a positive 7 is 7p. 9 on the inside, so this is our outside. Okay, so outside. Alright, and 9 times p, 9p, and there's our inside. Okay, and when we combine these two, we get 16p, which is good. But here's the thing, when we combine them, we get a positive 16p. But what we notice is in the initial problem, we want a negative 16p. Okay, so when we run our check on our outside and inside, we're not getting the middle term that we want. So we have to change some things. Okay, so let's try something here. Alright, now we had the positive 16 when we did our outside and inside combination, and we said we needed a negative 16. So the fact that we're getting a 16 makes us feel good that we have the right numbers. So that since we're seeing that we got the right number but the wrong signs, let's just try changing our signs. So instead of having these plus signs in the middle, let's switch and let's go with negatives. Alright, so we check again. First times first gives us the first up here in our trinomial. Last, negative 9, times last, negative 7, gives us, look, a negative times a negative is a positive, so we still get positive 63. So that works. We're good there. Okay, now back to our outside inside. Outside, we have p times a negative 7, which is negative 7p. Inside, negative 9 times p, which is a negative 9p. Negative 9 and negative 7 gives us negative 16p. So these two combined do give us the negative 16 that we wanted. So that lets us know we now have the right pair of factors, which are p minus 9 times p minus 7. Okay, so we check our answer choices for number 4. A says p minus 7. P minus 7 is one of our selections, so we hold on to that. We think that's the answer. Let's double check. We have a p plus 7 for B. P plus 7, not over here. We have a p plus 9 for C. P plus 9, we look over here, not over here. And D is p minus 63. We look, p minus 63, don't have it. So what we thought originally, A would be the correct answer, p minus 7. Alright. So now, number 5. Number 5, we have 9x squared minus 9x minus 54. Okay, so now this one is a little different. Right, this one becomes a little more complicated because now we have a coefficient of 9 on this square term. And all the other problems, if you notice, looking back at problem number 4, when we look at the square term, the coefficient is just a 1. You know, there is no number in front of this p right here other than a 1. 1 is understood. When we look at 3, problem number 3, we see on this square term, on this x squared, the coefficient is just understood to be a 1. But now for number 5, we have this 9 here. Okay, so that makes it a little more difficult. Process is still the same. Problem just becomes a little more difficult. Okay, so once again, we're trying to figure out a first times a first. That gives us 9x squared. Well, we know 9 is 9 times 1, or 3 times 3. Okay, so hey, let's try 3 times 3. So 3x times 3x, alright, would give us 9x squared. So first times first would give us first. So now let's try 54. Well, one of our most common ways of getting 54 we know is 9 times 6. Alright, but we also know it's 3 times 18, 2 times 27, and always 54 times 1. So always anything times 1 itself times 1. Okay, but let's start off with what I figure to be the more common set of factors, which is our 9 and our 6. Okay, 9 and our 6. So we want a negative 54, so we can try negative 9 times a positive 6. We know in order to get a negative 54, one of the two factors has to be negative and the other has to be positive. Okay, so we have our first times our first gives us our first term, 3x times 3x. It gives us 9x squared, so that's good. Then we have our last, which is a negative 9, times our last, which is a positive 6. Negative 9 times a positive 6 does give us a negative 54, so we're good there. Okay, but now what we want to do, again, check outside versus inside. On the outside, 18x. On the inside, negative 27x. Now, when these are combined, what do we get? Let's see. Okay, we have negative 27 and an 18. Alright, does that give us a negative 9? Let's see, does it? You know what? Good thing came up here. Let's look at this problem a little bit deeper. What I'm noticing is, okay, back to what we're saying, when we combine these middle terms, we see that we get negative 9x, okay, which is what we were shooting for in the middle. So everything looks good. We have 3x minus 9 times 3x plus 6. Looks good, I know. Alright, but what we have to realize is that if we look closer, these factors themselves could be factored, because a 3 can go into this 3, a 3 can go into this 9, a 3 can go into this 3, a 3 can go into this 6. Okay, so the lesson learned here is we always want to look at every problem for factoring like we did problems 1 and problems 2. We want to always reflect on the lessons we learned in problems 1 and 2, which is always look to see if there's a factor that can be pulled out first, a GCF that can be pulled out first. Okay, so let's erase all of this. So now again, looking at our 9x squared minus 9x minus 54, we see that if we factor out a 3, because 3 goes into 9, 3 goes into this 9, and 3 goes into 54, or better yet, we could factor out a 3, but what about a 9? If we pull out a 9, then that leaves us with x squared minus x minus 6. Okay, so we found that although 3 could come out of these, 9 is the GCF, the greatest common factor. 3 would be a factor, but 9 is the greatest factor. So that's why we go with 9. And we pull out a 9, we're left with x squared minus x minus 6. So now we know that this trinomial here is going to be broken up into two binomials. So we want an x squared, so first times first has to give us the first, so x times x will give us the x squared. And 6 is either 6 times 1 or 2 times 3. And the fact that I know I want to get to a negative 1 in the middle, I say positive 2 times a negative 3. So let's see. Alright, first times first gives us the first. Last times last gives us the last. Outside negative 3x, inside positive 2x. 2x minus 3x equals, these combine to equal our negative x. So what we see is our answer is 9 times x plus 2 times x minus 3. So these would be our factors. Okay, so we look at our answer choices. Letter A for number 5, 9x plus 2 is not one of our choices. Letter B, 9x plus 9 is not a choice. Letter C, x minus 3 is a choice. Letter D, x plus 3 is not a choice. So our answer would be C. Alright, so that was a good lesson we just learned there, to always look to see if you can factor out, whether it be coefficients or variables. You always look to check that first. Again, just like we did in problems 1 and 2, you look to see if you can pull something out first. Look to see if you can pull something out first, okay, before you get into breaking down your trinomial into a set of pair of binomials being multiplied by one another. Okay, let's move down. Alright, so now number 6. Okay, number 6. Same thing. Same stuff. Alright. Number 6. Notice once again we have a coefficient other than 1 on the square term. And based on the lesson we just learned in the last problem, we want to check, is there a number that goes into 7, 52, and 32? Okay. Well, we know 7, the only thing that goes into 7 is 7 other than 1. and we know 7 doesn't go into 52 and 7 doesn't go into 32. Okay, so we're safe. We can't pull out a common coefficient. Okay, can't factor out a coefficient here. And we look, we have x squared here, we have an x here, but this 32 doesn't have an x attached to it, so we can't pull out any variables. Okay, so we're back to doing just our basic of sets of parentheses. So we have our 7x squared plus our 52x minus our 32. Okay, and we say 7, we know 7, we have to get it by saying 7 times 1. So 7x times 1x, so because it's a 1x we just write the x. So 7x times 1x is 7x squared. So first times first gives us our first. We know that, alright, because there aren't any other factors for 7. Now with 32 we have some choices. You have 16 times 2 to get 32, 8 times 4, 32 times 1. Alright, so got a couple of choices here for this negative 32. To me, the most common pair of factors for 32 is 8 and 4. So let me try those. So let me say I want positive 8 minus 4. Okay, positive 8 minus 4. I know that my factors have to be opposite signs because when I multiply them I need to get a negative 32. So that's why I said a positive 8 times a negative 4 gives me a negative 32. So again, 7x is the first, x is the first, and it gives us 7x squared, which is our first. 8 is the last, negative 4 is the last, and when we multiply 8 times a negative 4, we get negative 32, which is the last. Okay, so we're finished. Again, we're finished. This is an answer. Now we don't know if it's the correct answer. We don't know if it's a right answer until we check the outside-inside combination. So now let's look at that. So on the outside, when we combine, we get, what is that? A negative 28x. And on the inside, when we combine 8 and this x, we get 32x. Oh, excuse me, I'm saying 32. I'm looking at that 4 over there. This is just an 8. Alright, so it's just an 8x on the inside. 8 times x is 8x. 7 times the negative 4 is the negative 28x. So when we combine these, because they are like terms, 8x and a negative 28x, we get a negative 20x, and that's not what we want. We want a positive 52x. So even though we said we were finished, we see now that these aren't the right factors. So we have to try some different numbers, or we need to try arranging the numbers differently. Okay, so let's erase some of this. Alright, so let's look. The 7x times the x, the first times the first, we're confident is going to give us, again, our first here, because those are only factors for 7, or 7 and 1. So we know we have that right. Now I don't want to give up on this 8 and 4 yet. What I do want to do is try rearranging their positions. So instead I want to, let's say, put, okay, let me erase this. I want to put this negative 4 here and plus 8 over here. Okay, so we said first and first gives the first. Now let's look at our last. Negative 4 is the last, positive 8 is the last. Negative 4 times positive 8 still gives us our negative 32, which is our last. So that still checks. So again, we're finished. We have our two binomials, we're finished, but it may not be the right answer. We have to check by looking at the outside and the inside combination. Okay, so on the outside we get 56x, on the inside negative 4x, and when we combine these two like terms, that gives us positive 52x, which does check out. So positive 52x is what we were looking for in the middle, our middle term. So we see our answer is 7x minus 4 times x plus 8. Now I wish there was an easier way for me to tell you how to get right to the answer. There are some other methods that could be used for this, but still at the end of the day it's a trial and error situation where you're having to think of the proper factors to try to get you to the answer you're looking for. Okay, so again, what I'm showing you is just reverse FOIL method. Alright, so that is number 6, and so based on what we have here, the answer would be D, x plus 8, because of our x plus 8 right there. Alright, so erase that. Moving on to number 7. Okay, 7 is a good one because it takes us back to that lesson we learned a little while ago about making sure we factor on the front end. And so we're looking at 392 x squared and 288, and what we notice is that both of these coefficients, 392 and and 288, both of them can be divided by 8. So I could pull an 8 out of both of these numbers. Okay, so when I pull an 8 out, so let me write it up here, 392 x squared minus 288. Okay, I can pull an 8 out. Now let's check the variables, see if I can pull a variable out. I pulled out a coefficient. Now let me check for variables. I have an x squared here. I don't have a variable in my second term, so I can't pull out an x, because in order to pull out an x I'd have to have an x in both terms. Okay, so I can't pull out an x, so I just go ahead and write what's left after I factor out this 8. So if I said 392 divided by 8, I would be left with what is that? 392 divided by 8 is a 49, and I still would have the x squared. And then when I say negative 288 divided by 8, I'm left with a 36. Okay, now there's a couple things about this problem that gives me some indications about how I want to work it based on just how the problem is initially set up. What I notice when I'm looking at number 7 is that I'm dealing with a binomial. Alright, because this initial problem, unlike the others we've done, this initial problem is only 2 terms. 1, 2, only 2 terms. Okay, and so based on what we've learned for factoring binomials in this particular chapter, we know that as long as we have 2 terms and a minus sign in the middle, then what we're looking for is the difference of perfect squares. Okay, the difference meaning subtraction, so the minus sign of perfect squares. Alright, well, I didn't know 392 and 288 to be perfect squares, but what I do notice, if you come over here, when you factor out the 8, guess what you're left with? 49x squared is a perfect square, 36 is a perfect square, and there's your difference. There's your minus sign in the middle. So once I break the problem down to see that it's a binomial and it's the difference of two perfect squares, I know what that gives me is basically the square roots of these numbers as the sets of factors, one being a plus sign, one being a minus sign in the middle. So in other words, I keep my 8. I know the square root of 49 is a 7, and of x squared is x, so I say 7x, and the square root of 36 is 6, so I say a plus 6. Then I say 7x again, but now minus 6. So the square root of 49, and 49 is my first term, so my first times my first have to give me that. So a 49x squared is my first term, then, and I know it's a perfect square, then I just take the square root and use that. So 7 times 7 and x times x gives me 49x squared. Then I look at my last term, which is this negative 36, and I know I get a negative 36, and by it being a perfect square, I get it by saying the square root of 36 being 6, so 6 times 6. But notice, in order to get a 36, the signs on the 6's have to be opposite. So 1 6 has to be positive and 1 6 has to be negative in order to get a negative 36. So our first times our first gives our first, our last times our last gives us our last. So again, our final answer is 8 times 7x plus 6 times 7x minus 6. Now, as far as the order of these, it doesn't matter if you want to say 8 times 7x minus 6 times 7x plus 6. As long as you have these three specific factors, you're fine. You're not so much worried about the order here. Okay? So for this particular problem, looks like B would be our answer. Alright, number 8, moving on. In number 8, we look again to see if we can factor anything out. Is there a number that goes into 16, 56, and 9? Well, I know with 16 being the smallest number, I first check to see if 16 goes into the 56 and 49. It doesn't. Alright, so then I think about what else goes into 16, because if I can find everything that goes into 16 and check to see if they go into other numbers and they don't, then I know I'm clear. So 16 doesn't go into the other coefficients. After 16 comes 8, alright, because 8 times 2 is 16. 8 goes into 56, but 8 doesn't go into 49. Okay, so after 8, you try your 4. 4 goes into 16, 4 goes into 56, but 4 does not go into 49. Okay, then you try your 2. 2 goes into 16, 2 goes into 56, 2 does not go into 49. So we can't pull anything out here. Alright, but once again, like the last problem, even though we had to factor number 7 first to see it, we realize we have perfect squares again. Our first term is a perfect square, our last term is a perfect square. Alright, so let's just deal with it as such. They're given to us as perfect squares. Tell yourself that when you see perfect squares as the first and last term, it's typically not by accident, it's intentional. So if we know we're dealing with perfect squares, let's try to factor them using their square roots. Okay, so let's just jump straight to their square roots to factor. Now there's a traditional setup because it's a trinomial again. Number 7 was a little bit different because again it was a binomial, 2 terms, 1, 2. There's a trinomial, so we have 1, 2, 3 terms. So this is like the other problems we've been doing. Alright, and we say our first term and our last term are perfect squares. So that should be a red flag to us saying, hey, they're perfect squares for a reason. So to get my first, I say first times first. and notice these numbers that I chose are the square root of 4. Square root of the square root of 16. Square root of 16 is 4. Square root of x squared is x. So I just wrote the square root of my first term down here in the first position of both binomials. Now when I look at my 49, which is my last term, I know the square root of 49 to be 7. So I have a 7 and a 7 in the last position. Now, because I know it needs to be a positive 49, I know I have to either say positive 49 times positive 49. Because I want a positive 49 here, I know this has to be a positive 7 or plus 7 times a plus 7 to get that 49. Okay, or a negative 7 times a negative 7 to get that 49. Alright, but the fact that this middle term, this 56x, is positive, that tells me I want to make these plus signs here as opposed to minus signs. So let's check. First times first gives us the first. Last times last gives us the last. Outside 28x, inside 28x. 28 and 28 is positive 56. So we got it right. So really 4x plus 7 times 4x plus 7 will be the same as saying 4x plus 7 squared. Okay, so 4x plus 7, answer being letter A. Clear? Okay, number 9. We have again a traditional setup, trinomial with a 4 coefficient on our x term. Check to see if we can pull anything out. 4 does not go into 23. Another factor 4 being 2. 2 does not go into 23. So I know I can't pull out any coefficients. I look at my variables. I have an x squared here. I have an x here. But no x's on the 72, so I can't pull out any variables. So once I check that, then I go to my setup. So I write my 4x squared plus 23x minus 72. Set up my two sets of binomials. Okay. For my 4x squared, I'm going to just go with 4x times x. And for my 72, most common being 8 times 7. 8 times 9. I'm saying 8 times 7, looking at the 72. 8 times 9 being the common factors for 72. Okay, and because of the negative 72, I know that I have to have one of the numbers is positive, one of the numbers is negative. So let's look. First times first gives us the first. Last times last gives the last. Okay, on the outside I have negative 36. On the inside, positive 8. Okay, so when I combine these, I get, what is that? Negative 28x. Is that right? Okay, not what I want. That is not what I want. I want a positive 23x. So I have to change some things. So let's see what we can do here. Okay. Alright, so I'm going to keep my 4x and my x for my 4x squared. I'm going to keep that. And I'm going to work with my 8 and my 9. And actually, I like my 8 and my 9. I just want to change positions of them. So let me move these two guys. Let me put my minus 9 here and my plus 8 over here. So now first times first, again, still gives me my first. Last, negative 9 times last, positive 8, gives me my last, which is a negative 72. Outside, which is 32x. Inside, which is a negative 9x, when those combine, 32 minus 9, or negative 9 plus 32, however you want to look at it, gives you a positive 23x. So we know we have it. So 4x minus 9 times x plus 8. 4x minus 9 times x plus 8. So let's see here. X plus 8, there it is right there. So that would be our answer. Okay. And the last one, again, it's a different look because we're looking at, well, I don't want to confuse anybody. Okay. This is all I meant to circle. Didn't mean to circle part of the answer choice. We're looking at a binomial again as opposed to a trinomial. Binomial, 2 terms. The majority of the other ones we've been doing have been 3 terms. 3 terms. 1, 2, 3. 1, 2, 3. Okay. Now we're looking at 2 terms. 1 term, 2 terms. So tell yourself when you're factoring 2 terms for this test in particular, you're usually going to be dealing with the difference of perfect squares. And what we notice is y squared is a perfect square, and we know 9 is a perfect square. So we go ahead and set up our parentheses. We know our first is a perfect square, so we use the square root to get it. Y squared is simply y times y. We see our last is a perfect square, so we use the square root to get it. 3 times 3. Seeing that we have a negative for that 9, we know that signs have to be opposite, so we use a plus 3 and a minus 3. So let's check. First times first gives us first, which is y squared. Last times last. 3 times a negative 3 gives a negative 9, which is the last. Outside we get negative 3y. Inside we get positive 3y. And notice 3y minus 3y cancels. That's why we don't have a middle term. Notice there is no term that's just a y. It's a y squared term, then a term without a y, as opposed to a term with a y squared, then a y, then a constant. Okay. Alright, so there it is. That wraps it up for us. Again, hopefully this helps you understand factoring a little bit better, and we'll be following this session with our last session, which will be graphing. Thank you.